So please welcome from Daimler, Steve Nadig and Alan Pearson.
Great, thank you. Hi, everybody. The title of this presentation was called something like 40 tons, 0 drivers. So part of that title is right, the 40 tons part is right. 0 drivers, actually, we don't foresee a time for, in our vision where there will actually be trucks with no drivers in them. So just to make everyone feel comfortable. We built a concept vehicle to showcase advanced safety systems, and we called it the Inspiration Truck. I'm going to kick this thing off with a video to just show you what that thing looks like.
Our inspiration is what makes our customers successful. Freight volumes rise and trucks become more important. That's why our engineers are already developing innovative solutions for the future. We're thinking, what's next? How will we drive tomorrow? What if the driver would not have to control his vehicle on his own? Intelligent safety systems would support him. His truck would bring him and his cargo to their destination safely. What if the vehicle could think with us? It would take over the driving routine on highway straights at optimum speed on the optimum route. Resources would be spared and transport would become more economical and effective. What if the driver could be free to do whatever he wants? His duties would be redefined. He would become a logistics manager while driving. An autonomously driving truck, that is our vision. And it becomes reality because the future is now. The next historic milestone is set by Freightliner.
All right. First of all, our company, we're a customer-driven company. We don't invent technology for technology's sake. We have to have products that provide value to our customers. These trucks are tools for our customers. They help them make money, they help them earn their livelihood, and as our CEO says, our customers don't buy a truck because they want a truck, they buy a truck because they need a truck. So all of this work goes into providing value to our customers. We focus on 5 technology pillars. We've got fuel efficiency, safety, connectivity, uptime, and reliability. We're going to focus on a couple of these areas right now. In the picture to the left, you'll see a current production model we call the Cascadia. This vehicle is a market leader. It's a top seller in the US. It delivers about 8 miles per gallon, but on a pound per pound basis, that's about 8 times as efficient as your typical SUV. It continuously checks its health, reports diagnostic issues back to the home office, communicates where it is, and helps the company operate their business more efficiently. It also is equipped with advanced radar. It can help the driver brake if he gets into a situation he didn't intend. It also can see the terrain ahead. We have terrain mapping systems in here where we optimize the performance of the vehicle to get maximum fuel efficiency based on the terrain it's on. The center truck shows a different concept vehicle we built just previously. We call it the Super Truck. This truck was focused purely on fuel efficiency. It had technology all over the vehicle to maximize the fuel efficiency it can get. This vehicle, pulling a loaded trailer, gets about 12 miles per gallon. On the right, you see our Inspiration Truck. This vehicle we're talking about today was built to showcase advanced safety technology and offers automated longitudinal control as well as lateral control of the vehicle. This whole thing started when Mercedes did a demo in about September of 2014 on a closed track in Europe. They demonstrated an autonomously driving truck. A month or so after that, the head of the trucks division kind of made a request to us that he wanted to do something similar here in the US. And we're real busy and we don't want to build concept trucks and we're working on this stuff all the time, so we kind of ignored it. Another month went by, you know, request comes in a little bit stronger. We really want you guys to do this. We go, yeah, come on, we're too busy. We're already working on this stuff. And then December of 2014, we got a very specific request that said, you will do this in Las Vegas on May 5 next year. And by that time, you know, panic set in and all hell broke loose. And we were trying to figure out what the heck we were going to do to meet this requirement. We pulled it off. We're really talking about the technology underneath, but if you know Freightliner and Daimler, we don't do things halfway. We wanted this vehicle to look different on the inside and out. So beneath the technology, or above the technology, I should say, we started from scratch with sketches. We went to clay models. Clay models got digitized, molds got made, parts got produced. While all this was going on, we had to adopt the technology that we were trying to demonstrate to these vehicles. So we had vehicles running in parallel, developing the technology that would eventually be underneath these cosmetics. Part of the technology here, we're really talking about steering systems that can control or be controlled by a computer. We're talking about braking systems that can be controlled by computer. And the computing power it requires to keep all this stuff in line. So this was going on in parallel to all the cosmetic stuff. Meanwhile, not only did we want to show this on a closed track, we wanted to do it on public highways. So we started working with the state of Nevada, who was very helpful to us, and they set certain requirements upon us to become legally licensed in the state of Nevada to operate an autonomous truck on public highways. Part of that requirement was that we had to accumulate 10,000 miles of incident-free driving during all this. So we had these parallel activities going on: cosmetic parts, technical parts, mileage accumulation. So this next video shows some of the mileage accumulation occurring on a closed track in Germany, actually. We did some of this testing here. Trained driver on a closed course here. Don't try this at home. You can see the vehicle steering itself. Here's following another vehicle. You have longitudinal control. Again, some crazy guy playing with his cell phone, following the vehicle. And eventually, we accumulated 10,000 miles. You get a warning here telling the guy he needs to take control and get off the road, and I guess he probably should have a while ago. In the end, we became the first licensed commercial vehicle to operate on public highways. The photo inset, you can see the governor of Nevada handing the official license plate to the head of trucks, Wolfgang Bernard. In addition, I'm quite proud of one of my employees who became the first licensed autonomous driver in the state of Nevada. Now, I don't know how much skill that takes to be an autonomous driver, but anyway, it was a first, so we're quite proud of it. And then when all this got done, we had just a small party in celebration at the Hoover Dam. We invited some of our best customers, we invited the press, we introduced the technology, and we projected on the face of the Hoover Dam you know, some video displays and whatnot, something like 1.2 million lumens of light output, which set a record at the time. I hope we still hold the record, but anyway. That was the celebration at the end of it. So now I think Steve, I'm going to turn this over to you.
Thanks, Al. So I'm Steve Nadig. I'm going to take you through a little bit about how the truck works, but you know, in Al's perfect form, the first time we went out and drove it together, he looked at me and said, "Boy, your driving really improved after you got that in." So just to reiterate a little bit, what we developed with the Inspiration truck is our Class 2 autonomous driving vehicle. It goes from 0 to 5, 5 being fully autonomous, 0 being no anonymity, if you will, 2 right in the middle. It still requires a driver behind the wheel. What the vehicle does do, though, is it accelerates, it'll stop, and it will keep you in the lane in terms of the steering. And the way it performs is really pretty simple. If you can see the red button, you see the two red buttons, and then down below it there's a red switch. That switch, you turn it on, the vehicle will check all of its sensors and it will tell you that Highway Pilot is available for you. The next thing that you do is even simpler. You set your cruise control at the speed that you want, and it will go into basically the autonomous mode. And the guys who did the graphics on it, it was fantastic. The screen changes. It's almost like you go to a new level in a video game. It's outstanding. And if you were to lose one of those sensors along the way, the vehicle will tell you to take over. I think you saw that in the video, and that lower right-hand portion also shows you where you're going to take over the vehicle. How does it work? It's relatively, I would say, simple. Steering control is done through a servo on the gearbox, a camera, and then an ECU. My wife told me not to use terms. Electrical control unit behind the scenes. And that will basically keep the vehicle centered in the lane. It's taking all the information in from the camera, where the two lines are on the road, and it steers the vehicle. Acceleration is done through the engine controller, and that will bring you up to cruise control speed. It also automatically shifts the automated manual transmission, so that gets you up to speed. And then braking is through the radar and through the ABS system. We have a radar out in front of the vehicle, telling you if there are any objects out in front, and if there are, it'll break you down. I'll take you all the way down to 0 miles an hour. Relatively simple on its functionality. One of the features, make sure I've got the right one. One of the features that is not part of autonomous driving that's on the vehicle are the mirror cameras. And I think they're really cool. What we were able to do is take a traditional Class 8 mirror and shrink it down to the minimum legal size. And we put 2 cameras in each mirror, one of them looking to the back and one of them looking kind of down and forward. So where you would have, a mirror on the hood and you could try to see the blind spot, now we have a camera looking into that blind spot. And then the cameras going to the back were outstanding because you had a chance they would track the trailer. Anytime that you would turn, you'd see the end of the trailer and where it was, instead of having to lean into a mirror or look at the convex mirror and see where the end of your trailer was. So again, that was a big safety improvement. Why would you want this vehicle? Al talked a little bit about technology for technology's sake. Why would a customer want this vehicle? Why do you feel safe about having it on the road? One, you've got all the safety features on it, the radar, the steering. It's just adding to the driver's capability driving down the road. So that's one thing. 2, fuel efficiency is another reason why our customers are going to want this vehicle. We'll get further into vehicle-to-vehicle communication, and vehicle-to-infrastructure communication, but it'll allow the vehicle to move seamlessly through urban areas, not having to speed up, slow down, and even get into a thing called platooning that I'll talk about in a little bit. The other portion that you do at a constant speed is you're not going to have as much wear and tear or maintenance on the vehicle, so you're not braking abruptly or accelerating abruptly, you're going through at a constant speed. Those are some of the benefits that this technology can bring to the marketplace. Talked a little bit, kind of led into this. This is vehicle-to-vehicle communication. Last month in Germany, Daimler presented this. We called it Highway Pilot Connect. This is really platooning. This is one of the next stages that we're getting to in terms of autonomous driving. But what we've done here is linked 3 vehicles together through vehicle-to-vehicle communication and allowed them to shrink down the following distance to about 15 meters, 45 feet if I don't do the conversion exactly right. Somebody's out there, a mathematician, it's 3 point, anyway. It allows us to shrink them down, and then each vehicle gets an aerodynamic benefit from driving that closely together. That's one of the real things that we see coming. Why is that a safe thing to do? A big portion of the braking is on the driver reaction time, and the vehicle-to-vehicle communication will take the driver reaction time out of that equation, and the following vehicles will be able to brake quicker, so we end up in a safe environment. So really quickly, I'm going to sum up the technology that we brought and showed today. One, we talked about Highway Pilot, kind of the autonomous version of it. Two, we talked about the mirror cams that we thought were really cool technology. And then the platooning or the Highway Pilot Connect is the third technology. And all of that is now part of the core of where we see the future of trucking. So with that, I'm going to bring our moderator out. Greg, see?
Think.
Yep. Thank you.
Thank you.
Thanks very much. Yeah, that's a wonderful, wonderful presentation, and it's really a privilege to have engineers presenting to us that we can talk to. So many technologies seem to be imposed on us. We don't get to talk back to the people who created them, and today we have a chance to do that. So I think this is really, really great, and also I compliment them on their bravery in leaving the lab and coming out and addressing us. So I wanted to open up to questions. I have one or two of my own, but I thought people would respond to your vivid, clear presentation, and maybe we've got some questions already.
You didn't envision a time when there wouldn't be a driver in the vehicle. I certainly do, and I'm wondering. And I'm sure a lot of your interested parties that are drivers themselves probably have a lot of anxiety about that future. I'm wondering why you guys are kind of firm in that conviction.
Well, yeah, I'll start off with that. You know, the technology does exist, and it certainly would be fine if your environment is controlled. Public highways are rather chaotic and unpredictable at times. And that's you know, if we can somehow do something to eliminate unpredictability and improve sensing, then of course we see that as possible. But as long as, you know, you have children running out and cars darting in and out of wherever and things are not so controlled, we think it's going to be a while until we can ensure safety in all conditions. That's the key thing, ensure safety in all conditions. So we think this technology certainly helps make the vehicle more safe. It can help a distracted driver, but the thing is safety in all conditions. So that's why we made that statement.
I think there's a social aspect of it too. I think, you know, you're probably open to it, but I'm not sure that everybody in the room is as open to it. I think about getting on an airplane without a pilot, and there's that social aspect of people being nervous about that technology. I think the technology will go faster than society's ready to react to it.
Good point. Yeah.
I'm really interested in the fleets, and I'm wondering what the limits are to that. Are we looking at a future where we're going to have virtual trains rolling down the highway with hundreds of trucks in tow?
I'll let you handle
We
that,
can both
yeah.
comment on that one. Certainly possible. Some things would have to happen to make it a reality. The vehicles would have to be very compatible in terms of their technology and their capability. For example, if let's say two trucks were electronically compatible, they could connect, but let's say the truck in back had bad brakes on it or something, then you have some issues that you need to deal with. So, you know, what we kind of see is possible near term or pairing or platooning very, very compatible trucks. The 100 truck thing, that might be quite a stretch. You can envision how it's possible technically, but there's some other aspects that come into play there.
There's some market forces out there that do it too. That will the fleets be even willing to do that, or how do you retain your competitive advantage among the fleets also? That's another part of the equation.
Yeah.
I have one up here.
Outside of the social aspect of this, what other dominoes do you see that have to fall in place, such as Fed regs, states playing along, et cetera, to make this a reality? And a second follow-up on that is, how do you see the disruptive energy sector affecting the profiles of your trucks and the future of your trucks?
quite catch the last part of your question about.
Energy, I can touch on that one.
Solar, name it, battery, lithium, et cetera, the new nanowire technology in batteries.
Well, go ahead and hit the first part of that if you want, and I'll hit the second. So, or you want me to hit the
Yeah,
second?
go for it.
All right. So we continue to, having superior fuel efficiency continues to be a significant benefit to our customers. So we're going to continue to work on that, and it's a multi-front attack. It's aerodynamics, it's friction, it's predictive powertrain control, advanced combustion technologies, and so on. So fuel efficiency will continue to be important. For trucks like this, the over-the-road vehicle, the efficiency of hybrid systems, doesn't really play out if you evaluate the physics. We're working with kinetic energy by monitoring terrain there. So hybrids in this size of vehicle, in this operation, this over-the-road operation doesn't work. Around town, it's kind of a different story where you have lots of starts and go. Solar, there's just not enough energy there to get much out of it on a truck. Although our super truck, we did actually have solar panels on the roof of the trailer, so it does provide a small benefit. So hope that answers the economics part of it. We think, clean, for this size of vehicle, clean diesel is actually, the way the power is gonna come for the foreseeable future, so.
I'm gonna,
You want to take the first
I'm
part?
gonna ask a quick question.
Okay.
A lot of the motivation is, of course, to benefit drivers, benefit safety.
Sure.
And to make use of the available technologies. And in the commercial setting, we have already seen that airlines have done much to assist the pilot. And fly-by-wire would be, in some sense, the trajectory you would see for commercial trucks. You're assisting the drivers. But one of the unintended consequences of all this assistance is skills atrophy. The idea that, well, the hope is that when the human is called, the human will respond in the appropriate way. One concern in general is that the dependence on these assistance forms might cripple or handicap human drivers when they're called. And how, a simple thing is we don't remember our spouse's phone number anymore. We're asked sometimes for our own phone number. We don't know. So how do you anticipate, use foresight so that the benefits are delivered, but the problem of skills atrophy doesn't become critical?
I like this question. One of the things that we didn't bring in one of the slides is we actually did some work with the drivers and hooked them up and measured them on what their driver workload and what their stress was using this technology. And we found that it got them down to really an optimum level in terms of being aware, but not necessarily being unalert in the situations. I think that's one aspect of it. Two, it's highway pilot, so there's still the skills of driving the truck in the urban environment to and from the depot. So it's only going to be, right now we're only on the highway. I think that's another aspect of it. And I don't think we finished the question out there, but we're looking at it from a national level. I think you asked the question of how do you see states and the national legislation of autonomous vehicles coming. One of the reasons why we had the Inspiration Truck was to inspire the discussion. That was the whole reason for it. And we're looking at some type of a national direction on autonomous driving. Sorry.
But
Yeah.
I think for
Yeah.
policymakers, that's going to be one of the things they
Sure.
address too, is
Sure.
just when does a human have to do what?
Yep.
And it may be that gets legislated, that humans still have to do certain things, maybe to make sure these skills are still sharp. Yeah, so it's a little bit of a chicken and an egg problem until we get going with this. Yeah,
thing with Google being recognized now by the National Transportation Safety Administration as the driverless car as a driver that happened like 2 months ago. Is there anything that creates a roadmap for the future for what we can do with this kind of technology?
So what about Google? Why won't they make all the cars in America? Why won't Apple make a car? Why won't Apple and Google just make everything, including food? Why won't they start feeding us soon? But yeah, I mean, this is a concern. You don't want to be bought by Apple and then become Apple trucks. You've got to stop these guys. That's why you're here. You're one of our only hopes to stop them.
Well, I think to that point, you know, a lot of people are working on autonomous systems. Obviously, you know, the car companies, Google, whoever, everybody's working on that. And, you know, my take is it's pretty simple. We want to make vehicles safer, and if the technology you develop during this autonomous research leads to that, it's a good thing. So I mean, I think that's, in my view, that's what's behind that.
Can we take one quick final question? Maybe somebody that's near the mic? Yeah, on this, okay.
Given the commercial uses currently of potentially autonomous trucks, do you see any impetus for creating embeddable technologies in roadways?
So the smart highway, the smart road?
Yeah, I think that's really where the whole V2V and V2I discussion comes in. I think there will be certainly infrastructure for the vehicle to infrastructure coming in the near future. That's going to be a lot of how do you get traffic through in and out of urban areas, alert people of accidents that are out there. I see that infrastructure coming for sure.
I do too. It's a little more, it's another way to add a little more control to the chaos on the highway. So if you can reduce the chaos, you know, then you can do some more things. So, yeah.
Well, thank you very much. Fascinating. We're going to hear a lot more about this. Thanks a lot to Daimler. You guys are great.